right? But that's what's actually happening to the point. So if you want to know where that point went, 6 plus 3, it's now at 9. 2 plus 1, it's now at 3. That point moved to 9, 3. I didn't have to graph it to figure out where it moved, right? I just added the values. Same thing with the next point. So it was at -8 and -2. Let's add 3 to that x value. Let's add 1 to that y value. And I can find that this point moved to -5, -1. So if I had a point that started, let me do one more column here. At m, n. Where would that point now be? It would now be at m plus 3, n plus 1. That would be the new location of that point. I don't know where m and n are, but I know that it's gone 3 right, 1 up. And so you can apply it in general terms like that. Okay, let's try the next one. Y equals f of 2x minus 5. Horizontal effects on that one. The 2 would have a horizontal effect. That is my b value. Yeah, so the b value is 2. The value of b is 2. The factor at which it multiplies is 1 over 2, right? But when I talk about the literal value of b in function notation, the value is 2. And it has a horizontal, I don't have enough room here, so I'm putting HS, horizontal stretch by a factor of 1 over 2. The b value is 2. Its effect is 1 over 2. Awesome. My vertical effects for this question is my k value, which is -5. If k equals -5, it's going 5 units down. Okay with that? Just the wording? The technical wording should have been like vertically translated 5 units down, right? But we just don't have space in these boxes. Okay, let's move our points. So my point is 6, 2. If I want to know where that point went, it would be 6 times 1 over 2. The y value would be 2 minus 5. Right? That's how you actually apply what's happening. You take the factor of 1 over 2, you multiply it by 6, it's now at 3. You take the y value of 2, you move it down 5, so you subtract 5, it's now at -3. That point moved to 3, -3. The next one, -8, -2, would then move to -4, -7. Right? I multiplied the x by 1 over 2. So -8 times 1 over 2 would be -4. I took the y value and I subtracted 5. -2 minus 5, -7. My point mn. I don't know where m and n is. But I know that the m value is now being multiplied by 1/2, and the n value is now being subtracted by 5. That point has moved to m times 1/2, comma, n minus 5. Are we okay with like the general term one, the m comma n? Because that pops up on tests, right? That's why I want to make that extra column. That is for sure like a test type question.
So would the test just like not tell you the numbers and it'd be like what would happen to m and n, and then you just write it up like that?
Yep. And that would be literally the answer on your test. Okay, last one. There you go, a box right here. Okay, the last one causes us a problem. The reason the last one causes us a problem is this is not h. Your h value is not 8. It is definitely not -8 either.
That's ridiculous.
Yeah, it's because your function should have looked like this. Notice the brackets. The b value is outside the brackets. They have multiplied it in. So you need to rewrite that by factoring the 2 out. That means my b value is -2. The h value is -4. That happens all the time. So now that we're like at this point where we just have all these transformations combined, you have to make sure you always separate b and h. This was technically b times h. It was not just h. By factoring it out, then you can figure what h really is. Yeah, but
how do you know if it's not supposed to be -x though, and then it's like you're taking on a -2 instead of just 2?
It will always be positive x.
Yeah,
So like
but if the x was if it had a negative, that would mean you're reflecting.
Like
if the 2 just came out and you left -x.
Yeah, so if you left like this.
Wait, we divided 8 by 2, but the 2 stays?
I factored out a -2. I did a greatest common factor. Okay. I'm going to answer that first so they can understand what I'm saying to you. This is what we started with.
Yeah.
I GCF the -2. So I divided it out. So it became the monomial. And then this is what's left over when I divide by -2. So -2 divided by -2 disappeared. Positive 8 divided by -2 became -4.
Because you're just trying to separate them.
Because it has to look like this.
Yeah.
Yes. Okay, now Blake's question was, what if you left the negative inwards? So if you had factored like this. Like that? Okay, that is not in any kind of form. So this negative is like a -1, right? So I would have to GCF that negative out.
Doesn't that just mean that you're reflecting above the x-axis? So there's a negative?
It does, but because it's in the brackets, the negative is affecting my h value still.
So then you're always going to have a value when it comes to a reflection? Wait, like that?
Okay, hold on. One question at a time. Okay. So do you see what I'm saying? If this negative is in the brackets, then it is technically affecting the h value, which we don't want it affecting the h value. So you GCF the negative out so you can see what the true h value is. Both equations here are having a reflection. This one has a reflection because the b is negative.
Yeah.
This one has a reflection because the negative is on the x. The difference is this one, I can tell what the h value is. It's +4. This one, the h value is not right. It's wrong.
It's -4.
It's actually -4 the way it looks right now.
Yes.
Right?
Yeah.
So by taking the negative out, then I can know what's actually h. That answers that question?
Yeah, I think so.
Yeah.
Just factor with the negative.
Yeah, never let the x be negative. Like move it out front. Okay, Em, go ahead.
So then.
Sorry, that's hard.
So when you're wanting to have the reflection go like that, you know,
Yep.
and it's applied beside the x.
Yes, but like you want it, you don't want this. Like you want to take that and put it out front. That's what I'm getting
How
at.
do you get a reflection like that? Like, do you have to have a value after?
That would go here.
Oh, okay, then like that. Like.
Yes. Okay.
Okay.
No, I see
So
what you're
it has
saying.
to go with the b, not the
It
x.
has to go with the b, not the x. The x is always positive. So when you look at our form, like look at our general form here. This is our general form. There is nothing in front of this x. Ever. The only time we were getting values in front of this x, like the question above, is because there was no h. Right? Like this was, I'm going to rewrite this one. With an h value, it would have looked like this.
But if the thing stays as 2, like in the question, how come I couldn't read the third one as you keeping the 8 there and reading the -2 still as your b factor?
Yeah, the b value is not the problem. The h value is the problem. Because h is not 8. Yes, because it has to be in this form for you to know what h is. And when we do see values right beside the x like this, it's because there was no h value. This was x minus 0 the whole time. Right? There was no x value. And then you multiply it in, you don't need to write 0. That's why they're allowed to write it like this in that instance. But if you have a b and you have an h, it must be factored out, and it must look like this, with nothing next to the x. Okay.
How do you know it's not an A value?
Because that's a great question. He's saying, how do you know it was 2x minus 8 plus 8, right? Yeah. So he's asking, oh, sorry. He's asking, how do you know that -2 doesn't factor to look like this? And this is actually a question that came up before with something else. In function notation, when it's in the brackets like this, there is no way to bring it outside the brackets. I am saying that this is part of the function. That is taking it outside the function, which is not even possible at all. So anytime you see values in here in function notation, they're stuck in here. There's no combining them with k values or a values or anything like that. They are stuck in here.
It'll always be B.
It'll always become b. Yes. You cannot do that. And that's a good question because people do that all the time. They want to combine h and k values, right? Like they're side by side adding and subtracting. Why can't you add them and subtract them? It's because one's part of the function, one's on the outside, it's not part of the function. Cool. So now I actually do know my h value. My h value comes from there. My h value equals +4. All right, because it's the opposite of what it looks. That means that we went 4 units right. We have another value that is affecting the x values, another horizontal effect. I have a b value of -2. Yeah, like when we do these in order. Actually, you know what? I like that. I should have written it in order. Am I going to be able to do that? No, I'm not. I'm going to leave it like that then. We'll talk about it in a second. My b value is -2. That would have a horizontal effect. It have 2 effects. What are the 2 horizontal effects? Yeah, Maddie?
The reflection
It's a reflection.
Stretch by a factor of a half.
Yes. Reflection about the y-axis. And stretch, horizontal stretch, so HS, just because I don't have space, by factor of 1/2. So the transformations that I had a reflection which takes care of the negative, and then I have a horizontal stretch of 1/2, which takes care of like the distance going to or from that y-axis. Awesome. My vertical effects. What vertical effects happen on this question? No vertical effects. Perfect. Awesome. Applying this to a point. When you're applying something to a point, we have 6,2, right? That's the original point. The order in which you apply them does matter. Okay, you must do reflections and stretches first. So that means B value first. So my B value was -2. So I'm multiplying by a factor of 1/2, but it is -1/2 because the negative gives me the reflection, like that. So I'm multiplying by -1/2. The negative gives me the reflection. The 1/2 gives me the stretch. That means this point is now at -3,2. Then you do H value. My H value was 4. I can't see my screen. So it's now -3 plus 4. Comma 2. Meaning that this point moved to become 1,2. The order matters. It's just following BEDMAS. Multiplication before addition. Right? Like BEDMAS would tell you multiply first. Let's try our next point. I can't see what it is. It starts at -8, -2. Okay. If I was to write this all at once, so if I was like, let's apply both factors at the same time, it would look like this. -1/2 times -8 and then plus 4. The reason I want to show you that all at once, there we go. It's because how would you calculate that? Like if I gave you that question and I was like -1/2 times -8 plus 4, like how would you go about calculating that? You'd follow BEDMAS. Multiplication has to happen first, then you would do your addition, right? The order in which you do transformations matters. It must follow BEDMAS. Multiply, then do your adding. B value, then your H value. This point would move. -1/2 times -8 would be +4. Add 4 more, it goes to +8, comma -2. Negative a half times negative 8 would become positive 4, not negative 4. And then add 4 to that. We'll take it to 8. 4 plus 4 is 0 sometimes. Okay, if you were to write this in general terms, so you have this point, m comma n. I have no idea where it is. There's several different ways that you could write this answer. I suspect this is what it would look like on a test, though. You would get negative 0.5 instead of negative a half. They changed to a decimal. So negative 0.5 m. Add 4 to that. N would not change. That's like the general form of what we're doing, right? Yes, sir.
So the test question would just be like, so if you get to this point from here, it went through these following transformations. Which one is it?
Yeah, so like if that was I'll write it quick. That was a test question. It could be written a million different ways, right? Like it's tough to be like, this is how it'd be written. But like a good example. Yeah. A good example of how it'd be written, it would be the point m n lies on y equals f of x. So the mn is on the original function, which is transformed to become y equals f 2x plus 8. Where is the point? We would say determine where the point. Where is the point mn transformed to? Like that's how you could see that same question. All right, you got a point. You don't know where the point is. It's on this original function. This function changes. It's transformed to this, which is exactly what we just did. Where is m and n? M and n. N and m. M and n. Right, like that's how you could see that same question. You'll see things like that in your practice book. So as you work through it, you'll see questions like set out kind of like that, more general terms. But it goes for a loop because like I don't know where the point is. I don't know what happened. I don't know what the transformation is, and it feels like you don't know anything about that problem when you do. We just did it. Right? Like you do know how to tackle it. Just think in general terms. When they start using letters like that, just think everything's in general. What's happening in general, and then apply that. All right, let's do some more questions. So sketch the graph of y equals negative 2 f x minus 2 and determine the domain and range. So the graph that they've shown you is y equals f of x. Right? It says it right there on the graph. If you look right beside the blue line, I can't do nothing. Page is unresponsive. Would you like to wait? No, I would not like to wait. I kind of have to wait, don't I? You're not going to give me a choice. Let's stop recording. Goodbye, world.